Well, hello. What do we got here? We got Tuesday, May 19th, and we're going to talk about strong acids today. And most acids are not strong. Most acids are considered weak acids, but the name's a little misleading. Weak acids can burn you if you pour them on you if they're super concentrated, and strong acids, if they're super dilute, cannot burn you. So concentration really matters more than the nature of the acid when it comes to how bad it's going to burn you or whatever. But the designation of strong and weak acids is important to when we're figuring out some chemistry math. So we're going to talk about strong acids this week and strong bases. So here's HCl, and that's hydrochloric acid. And hydrochloric acid is a strong acid. So when we put it in water, we can predict what it's going to do. We just have to think bad thoughts where bases accept protons and acids donate protons. So here we are with an acid, so it's going to donate a proton. And who's it going to donate the proton to? It's going to donate it to this water right here. So what we're going to end up with is a chloride ion all by itself because this hydrogen ion left it, and the hydrogen ion went to become part of this water molecule, and it transforms the water molecule into a hydronium ion. Yeah. So the deal is that with strong acids, this happens 100%. Every single molecule of hydrochloric acid that you put in the water is going to fall apart like this. It's going to donate its proton to the water and leave the chloride all by itself. When we say that a chemical falls apart in water, kind of like splits like that, the fancy word for that is dissociate. Like if you dissociate with your boyfriend, then your one unit is becoming two. So we can say that strong acids completely dissociate in water, as opposed to weak acids, which do not completely dissociate in water. So let me show you what I mean here. Let's say we took 1 mole of pure hydrochloric acid, and hydrochloric acid in its pure form is actually a liquid. So if we took 1 mole, and what's that mean, 1 mole? What that means is how many grams there are in 1 mole. So 1 mole of hydrochloric acid would contain 1.01 grams plus 35.45 grams. So that'd be 36.46 grams. That's how much 1 mole of hydrochloric acid weighs, 36.46 grams. So if we took that much hydrochloric acid and we put it in water so that the final volume of the solution was 1.0 liters, then we would end up with a solution of hydrochloric acid. And if I was doing this in the lab, if I was building this solution, I would go ahead and build it, and then I would get out some tape and I would label it. And here's how I would label it. I would say that this bottle contains 1.0 molar hydrochloric acid, and I would say who made the solution. So I'd put my name on there, and I'd put the date that I made it. So I'd put 5/19/20, like that. And then I could, transfer it to a bottle, transfer the tape to the bottle, and then let it sit on the shelf. And then there it would be for people to use. So that's what the label would say, but what the label says and what's really going on inside of that container are two different things. So if we looked at what's really going on, remember these square brackets mean concentration in units of molarity. So the concentration of hydrogen chloride inside of this solution, it seems like it would be 1.0, but it's actually not. It's actually 0 molar. There is no hydrogen chloride in here. The reason why is because hydrogen chloride is a strong acid. So when you put it in water, it completely dissociates. There is none left. It completely broke apart. So what there is chloride ion and hydronium ion. So the concentration of hydronium ion is going to be 1.0 molar. And the concentration of chloride ion is going to be 1.0 molar. And you could be like, well, Mr. Gady, that doesn't make sense. How can one thing break apart and turn into one and one? That doesn't make sense. You would have to start with two in order to end up with one and one. And here's what I'm talking about. Let's say that I had, I don't know, what do you call this? Highlighter right here. If I broke this highlighter apart like this, I'd end up with one pen and one cap. Yeah, because the highlighter itself is made out of two parts. And that's just like this hydrogen chloride right here. It's made out of two parts. It's made out of a proton, a hydrogen ion, and a chloride ion. So if you take it and you put it into water, it's going to break apart. And if I took 3 of these pens and broke them apart, how many caps would I end up with? 3. And I'd end up with 3 pens also. So that's what's going on here. In 1 molar hydrochloric acid, you actually have 1 molar hydronium and 1 molar chloride. If you had 0.5 molar hydrochloric acid, you would have 0.5 molar hydronium and 0.5 molar chloride. If you had 6 molar hydrochloric acid, you'd have 6 molar hydronium and 6 molar chloride. Does that make sense? Because it completely dissociates. So strong acids in college, you're going to have to memorize which ones are the strong acids and which ones aren't. I'm not going to make you guys do that because there's no need to. But I'll just show them to you anyway. So HCl, yeah, because this is good practice for us. What's the name for this? Well, the anion determines how you name the acid. So in this case, the anion is a halogen, and the rules for naming a halide acid are you start with the word hydro, and then you use the root of the anion, which is chlor. So it's hydrochlor, and then you add ic and acid. So this would be hydrochloric acid. Whereas this one right here, the anion is a polyatomic ion. It's nitrate. And we go ite, us, ate, ic. Oh, so that would be nitrate would turn into nitric. So this is nitric acid. Yeah. And this is sulfate. So this would be sulfuric acid. And this is bromide, so that which is a halogen. So that would be hydrobromic acid. And this is iodide, which is a halogen. So that would be hydroiodic acid. And this one is perchlorate. So that would be perchloric acid. Yeah. So that's the strong acids. What do strong acids do? They dissociate. How often do they dissociate? Cien por ciento, 100% of the time. They never don't. If you know the concentration of the acid, the strong acid, then you know the concentration of the hydronium, and you also know the concentration of the anion. You know it. So next time we're going to look at bases. Yeah, that's pretty sweet. See you guys later.